4, which is how we're going to look at, this is a big section. Right, there's a lot in this section. What we're going to do in 4 is look at the factor theorem and find the real zeros of polynomials. So we're going to use the division algorithm. We're going to use the synthetic division in order to factor our polynomials, because we want to use the factor theorem. We're going to analyze the polynomials when they have multiple zeros. How does it, how to interpret graphs when they have different multiplicities. Understand the rational zeros test and the rules that go with it, and solve higher degree polynomials. We're going to solve them by finding the factored form and the factors. Right, so again, this is going to be a lot of finding and factoring polynomials, which will, in essence, kind of look at, we're going to be doing synthetic stuff. We're going to be finding the zeros of functions and kind of understand the zeros and then divide them out like we did with synthetic division. Alright, so the factor theorem. A polynomial f of x has a factor, so this is kind of what we talked about at the end of the last set of notes. If my function has a factor, so it has a factor x minus k, if when I plug that k in, that number k in, I get 0 out. It's a 0 of the function. And so what that means is when I divide by this, right, my remainder is 0. It divides perfectly into the polynomial. Ergo, it's a factor, right? 4 is a factor of 12 because 4 divides into 12 evenly into 3, right? I get 12, which is 4 times 3. 4 and 3 are factors of 12, and so the same idea is going to be used for polynomials. Right? So when I can divide evenly, so dividing evenly meaning I get a remainder of 3, or when I get a remainder of 0, sorry. Dividing evenly I get a remainder of 0. And when I get a remainder of 0, that's telling me that when I plug that value into the function, I get 0 out. 0 is a factor. Alright, and so that's what we're going to do. So examples of where we can do this is we actually can come up with polynomial equations by doing this. Alright, so understanding the factoring theorem. So suppose that we know that a function has specific integer 0 values. Alright, so we know, we can find them. Either we found them, they were told what they are, or we're going to look at the graph of this. So we were given a graph, and remember on our calculator we can find the zeros of a function, and we're going to do that in this section. And so suppose I looked at the graph and I found the 0, the x-intercepts of my particular function f of x are at -2, 1, and 3. And so what that means is, when I plug -2 in, oops, I'm supposed to have a highlighter. When I plug -2 in, I get 0 out. And so by the factor theorem, that means x plus 2 was a factor of f of x. When I plug 1 in, I get 0 out, and again, x minus 1 is a factor. When I plug 3 in, I get 0 out, which means x minus 3 is a factor. And so I have those factors of my polynomial f of x. And so how that translates graphically and into the function equation. Alright, so suppose that I found these graphically. So I graphed a function. I'm just going to draw it here. And so when I graphed it, I found, so -2 was a 0, 1 was a 0, and 3 was a 0. Alright, and it actually comes up here and I found my x-intercept as well. Suppose that was at 0, 12. Alright, so suppose this was the graph of my function. So f of x, where again my zeros are at -2, 1, 3. And so what that means is those are factors of my polynomial. And so if it's a function, we're going to talk about later on where different things are happening, but if this is my function, where at the factors, the function crosses the x-axis nicely, and it does. At those factors, it crosses my x-axis nicely, meaning it's not bouncing off. There's no weird kink or shape in it. It's just nicely crossing it, smoothly crossing my x-axis. Well, if that's the case, then at the very least, I know my function equation is some leading coefficient times each of my factors. My x plus 2 times x, right? That's what factors are. It's the multiplication. 4 and 3 are factors of 12. When I take 4 and multiply it by 3, I get 12 out. Well, the same thing here. I know x plus 2, x minus 1, x minus 3 are factors, and they're my only factors, right, because those are the places that I cross. And so those are the factors, the zeros that I have, the real number factors. If I multiplied it out, I get my original function back. With one exception, there's an a out front, because I don't know if it stretched it or I didn't know if I had to stretch it. And so a, remember, is my leading coefficient, so I don't know what a is. It's my leading coefficient. But at the very least, I know a is positive, right? I know it's positive because of the shape of the grass. This is a cubic, right? And it's shooting off to negative infinity to the left, positive infinity to the right. So that means the shape is where my third degree polynomial, my leading term, should be positive. And so this is why I gave you a second point, or another point that's on my graph. I can use this point to figure out what that leading term, at the very least I know it's positive right now. But I can find it by using, I know I have the point 0, 12, right? And remember, 0, 12 means this is my x value 0, this is my y value 12. When I plug 0 into the function, I should get the y value 12 out, and that's what I'm going to use. So I know I should get 12 out when I plug in 0 for x. So I plug in 0 for x. Oops, that shouldn't have been 12, that should have been 3. Sorry about that. That should have been x minus 3, guys. Right? X minus 3 is my factor. I'll put a 12 there because I'm looking at the wrong point. So make sure x minus 3 should be there. Alright, now I multiply it out. And so I solve for my a. So I've got a times, well, negative 1 times negative 3 comes out positive 3 times 2 comes out 6. Divide out by 6. And so that means that leading coefficient was 2. And so my function, f of x, was 2 times x plus 2, x minus 1, x minus 3. And so there is the function that has the factors x plus 2, x minus 1, x minus 3. If I plugged in each of those, it will come out to 0. And satisfies this graph, which again, in order to find the leading coefficient, I did at least need one more point to do that, and I gave you the point 0, 12. So in order to know whether or not there were any stretch, and there was then, there would have been a vertical stretch by a factor of 2 in this case, because it came out 2. And so that's basically what we're going to get into in this section. We're going to be finding factors, we're going to factor our polynomial, so we're going to get to the polynomial equation, and then we're going to use that to solve equations. All right, so that's what we're going to get into in this chapter, or section.